Welcome back. In this video, we're going to talk about the chemical reactions of acids and bases, specifically how acids interact with metals and how they neutralize when mixed with hydroxides. We've seen these substances in isolation, but now we get to see the real fireworks when they start reacting with other materials. When an acid meets an active metal, a single replacement reaction occurs. The metal essentially kicks the hydrogen out of the acid. The two products you always get are a metal salt and hydrogen gas. If you've ever done this in the lab with magnesium and hydrochloric acid, you've seen it fizzing. Those bubbles are the hydrogen gas being released into the air. In chemistry, the word salt doesn't just mean the stuff on your French fries. It refers to any ionic compound formed in these reactions, like magnesium chloride or zinc bromide. It's also important to remember that hydrogen is a diatomic element, so when you write these equations, the gas product is always written as H2. That usually means you'll need to go back and balance the rest of the equation with coefficients. The second major reaction type is neutralization. This happens when an acid and a hydroxide base react. It's a double displacement reaction where the business ends of each, the H plus from the acid and the OH minus from the base, join together to form perfectly neutral liquid water. Because the acidic and basic properties cancel each other out to make water and a salt, we call it neutralization. To predict the products, we use the same partner swap method from earlier in the course. First, break the acid and base into their component ions. Then pair the positive ion from the base with the negative ion from the acid to form your salt. For example, reacting hydrochloric acid with sodium hydroxide gives you sodium chloride, actual table salt, and water. Always check your subscripts. If you're reacting hydrochloric acid with barium hydroxide, remember that barium carries a +2 charge, so it needs 2 chlorides to form a stable salt. BaCl₂. Once you have the correct salt formula, you go back and add coefficients, in this case a 2 in front of the HCl and a 2 in front of the water, to make sure the equation is perfectly balanced. In our final video, we'll see one more way acids can make things fizz by reacting with carbonates.